Equipment operation. Enter the ultrasonic pile test. Then click Parameter Settings. After clicking Parameter
we can start
Settings,
a new project.
Come up with a name. And then, of course, if you've had new projects
You can
before,
also
choose here. Well, then what? The name of the new pile. Click on this new. The name of the
Then
pile.
this piece.
You can enter a shape for the stick. What shape is it? You can enter it. And then here, enter the number of acoustic
We
tubes.
have
3 pipes. Let's enter 3 pipes. And this is the line spacing. It's a spacing of how high to lift. Collect data once. And there's a sensor down there. It corresponds to our receiving channel. Then the transmit channel is a receive channel. We are plugging in the receiving channel 1. That's it. Then here, let's measure the 1-2 section first. Section 1-2. And then what about this piece? Enter the spacing of an acoustic tube. The spacing between our EBR section acoustic tubes is 750. Then the spacing of 1-3 is also 750. And the spacing of 2-3 also is 750. This is the basic parameter. And the input
After the input
is completed, we can enter the advanced parameters. Enter the advanced parameters. What to enter first? Enter that first. System delay. System delay. Our system delay is 4.0. Then we can choose all the noodles. All use the same system delay. That's it. Then enter a what here. Enter an acoustic tube and an acoustic time correction value of coupled water layer. Click to enter. So let's start
What we
with
input
this. Is an inner diameter of the acoustic tube. Inside the acoustic tube, let's talk about the outer diameter
example,
first. The outer diameter is 50. Then the inner diameter is a 44. Then enter the diameter of the transducer. The diameter of our transducer is 25. Then the speed in the steel is input. Then enter the speed in the water. So it puts an acoustic tube and an acoustic time correction of
figured it
coupled
out
water
for you.
layer. Just click OK. Then you can choose the technical specification for
Select
this
piece.
one of our applicable technical
And this
specifications.
piece has a
sound speed limit. If you choose the sound speed limit, it will be within this speed range of sound. Go find the first wave for you. What if you don't choose? It doesn't have this speed limit. How about here? What you lose is a wave diagram, a number of parameters. This is a stretch of the poles. A ratio of stretching and compression. Usually we can do it once. And this is delayed alignment. This is gain normalization. Then you can enter it here, a track and spacing, a magnification, a multiple. This can be entered. Then it stops sampling when we pass ling. Then when it approaches 0 o'clock, in stoppage time it will. If you arrive at 0 o'clock, it has 1 or 2 undetected words. It will automatically fill you up with 1 or 2 points. Then this is a common parameter. Then enter other parameters here. Enter other parameters. Let's choose our host first. And a connection method for our improved counting wheel. We chose wireless connection. After selecting wireless
If we
connection,
can choose
this Bluetooth connection, give it first. Search for this counting wheel for it first. The first search will be slower. As long as you connect successfully after you turn it on, it will automatically connect. This found a number for our counting wheel. After, let's choose to connect. After connecting, when we turn it on again in the automatically future, connected. Don't do this step anymore. Return to this time. Enter our sampling interval. Sampling interval. The smaller it is, the sparser its waveform is. The larger the sampling interval, this waveform then choose the one that suits us. A sampling interval. And then this is the number of sampling in general, 1000 is enough for us. And then this is the emission voltage. What is the emission voltage? Your pile is bigger. That is, when the pipe distance you can turn is up relatively the transmit voltage. Turn up the transmit voltage. The pile is relatively you can turn small. The transmit voltage normally down 500 or 250. After this is all entered, it has a second interpretation here. One option. After you test all the piles, It will give you a second one, an interpretation of the first
After
wave.
choosing this,
Its first wave interpretation accuracy
what about
will be
this?
higher. Some of the first wave interpretation. Some methods. What about these two different methods? For different situations, choose the method that suits us. Didn't say which method is better. Just say which method is more suitable for waveform of the pile. We can choose to try it. Then see which secondary interpretation works better. Or we will not read this piece twice. After we export the data back, can be on the computer. Do a second interpretation. This is promotion. Device calibration. Lifting device calibration. Let's talk about this later alone. OK. Confirm again. This time, enter our sampling interface. Enter the sampling interface. Let's click to sample. That's it. First, we need to break this wave. Adjust to about 1/3 of the left side of the entire screen. Adjust with one finger. Move a finger from side to side. It adjusts the front and rear movement of this waveform. What is the adjustment of moving a finger adjust up and the gain down of this wave? That's a ratio of the stretch in the vertical direction. What shall we adjust? It's better to adjust to this whole wave. In the bottom half, at R1/3 of the display area in the lower half. Then the waveform stabilizes. Let's click the Stop button. And then this piece is the height of the input, our starting point. Because the position of our probe is. What is the location of the pile? It's 4 meters. 4 meters. But we're going to remove the nozzle, the guide wheel and that sonic tube. Show the height outside the pile. We need to run 30 centimeters Enter away. 3.7小时 air. 3.7 meters. This is okay. If you have a blockage, if used like the two channels of our two pipes, we generally don't need to be involved in this blockage. Setting. Just click OK. This time, we can upgrade this transducer. When pulling the wire, let's remember that if you use force, you need to if use you push force down, downward. We promise this line is tightly pressed against your counting wheel. It doesn't slip easily. Then when pulling the wire, let's pay attention to uniform stretching. Pull it up at a constant never speed. An even force. Because if you put the wire like this, the probe below is prone to shaking, cause waveform instability. So when we pull the wire, try to pull and lift at a uniform speed. Just keep pulling it to the end. At this point, we will start storing this data. Then when storing the data, we can be in this view. It can be modified in the view. Let's see the view below. This is a histogram. Then we can change to curve. You can also change it to a wave diagram. Let's see which one is more convenient. Those who operate the instrument should pay attention. Pay attention to this screen, a change in this waveform. And this piece shows our height. It has now been raised to 2 meters 16. Then let's improve the whole surface. Just raise it to the top. Let's click Stop. And this is just taking this whole section. The test is complete. So this is the curve of the speed of sound. The red curve is the amplitude curve. Then it has a red dotted line. The red dotted line is a threshold for the speed of sound. What about this red dotted line? Corresponds to the critical value of the amplitude. Which point is the speed of sound to the left of the critical value? That means the speed of sound at this point will be a little lower. Let's take a look at the waveform. Is the first wave accurate? This is the profile. After the test, let's click on the parameters. Click parameter. This time, we should test other profiles. This E.R is finished. The E.R profile test just now we are still no E-tube. The probe of tube E remains stationary. Then put number R. This received. This probe received. Put the probe in tube 3. Then it automatically selects 1:3 sections here. Then there is no need to operate here. Then OK. At this point, let's repeat the steps. This time, our E.R section has been tested. Then let's put this probe in tube 3. Put it in tube 3 and put it on the pile. That's it. Then let's put it at the bottom of the pile. Let's continue to click to sample. Sampling, then adjust its first wave. Let's save it after adjustment. Still 3.7 meters. Then OK, just improve the transducer. After this 2.3 profile is done, let's still enter the parameters. Then put this launch probe. Launch probe, put it in tube R. Come on. In this case, let's measure the 2.3 profile, or just continue the steps just now. The probe is placed at the bottom of the pile. Then adjust the first wave. Click Save when adjusting the first wave. Then 3.7 meters. Then click OK. And then lift it up. Our whole pile has been tested.